So how can I rewrite the first one? Start off with, what's my index?
2.
Index is 2. So I can rewrite this with a rational exponent. I have 3x minus 1. You said the index was 2, so that would go on the bottom of the fraction. What would go on the top of the fraction? This 2 right here. That's the exponent. That's going to go up on top. Well, what is 2 divided by 2? 1. So I have 3x minus 1 to the first power. And if something is raised to the first power, do I have to put the exponent there? No. So this would just be 3x minus 1. Does anybody want to take a guess at the final answer on number 2?
2x plus 5.
2x plus 5, absolutely correct. Tell me how to walk through that showing work. What do we know? Index is 3. So I have 2x plus 5 that is being taken to the power of something over 3, because that's my index. What would I put up in my numerator? 3, coming from right here. 3 divided by 3 would give me 1. So that would be to the first power. And that middle step right there where I'm writing the first power, you can skip that. If you notice that the index and the exponent match, we can jump right to the end. When the index and the exponent match, they will cancel each other out. We're going to practice this in your book today in the context of some solving problems. So big important takeaway from our bell work is when our index and our exponent match, they're going to cancel each other out. So if I have an index and I want to make it cancel, I can take the whole expression to the power of whatever my index is. That's how I can get it to cancel out. Page 343. Page 343. A radical equation is something that has a variable in the radicand. Oh, thank you, ma'am. Gotcha. Radical equation has a variable in the radicand. It is possible that we can get an extraneous solution, so we have to check to see if that happens. 3 steps for solving a radical equation. First, we're going to isolate the radical. So we're going to isolate the radical on one side. And then to eliminate the radical, we will raise each side to a power that is equal to the index. So if my index is 2, I'm going to square both sides. If my index is 3, I'm going to cube both sides. Whatever my index is, that's the power that I'm going to raise it to. Then we're going to solve it. And last, we will have to check. So let's practice doing that on example problem number 1. So we're going to walk through these 3 steps. What is our first step again? Isolate the radical. Then we're going to raise each side to a power equal to whatever my index is. So when we say isolate the radical, what is the radical in this problem? Yes, this right here is what we want to isolate. What do I need to do both sides if I'm going to isolate that? What is on that same side that I want to get rid of? The 2. Is that a positive 2 or a negative 2? Positive. How will I make that cancel? Subtract it. So I'm going to subtract 2 from both sides. So it's going to cancel here. 6 minus 2 would give me 4. All right, so that was our first step, isolating. What was our second step? Yes, we're going to eliminate the radical. So I need to know what the index on my radical is. What is my index? 2. So each side I'm going to raise to the power of 2. So I'm going to square this side. And if you do it to one side, you have to do it to the other side. My index is 2. And I'm raising it to the power of 2. So that's going to cancel. So I'm not going to have a radical anymore at all. On the other side, I actually have to square that number. What happens when I do 4 squared? We get 16. What do I do now to get x all by itself? Add 5 to both sides. They didn't give me a lot of room to do this, so I'm going to take a little bit more room than they gave me. That would be 3x then, right? 3x equals what? 21. How do I get it to be just x now? Divide both sides by 3. 21 divided by 3? X equals 7. Last thing we always have to do here is to check our final answer. So before I put a box around it and call it done, we're going to check that that actually works. So I'm going to go all the way back to my original equation. This was square root of 3x minus 5 under the radical, and then plus 2. If we did this right, it should equal 6, but I don't know if that's going to work yet, so I'm putting a question mark above my equal sign. What are we going to put in the place of x? 7. And so now I'm going to do all of my work just on this side. I'm not doing things to both sides. I'm staying on that side to see if when I simplify this, I get 6. So under the radical, what can I do? 3 times 7. What is 3 times 7? 21. So I have 21 minus 5 and then plus 2 right here. What is 21 minus 5? 16. So I have 16 under the radical and then plus 2. Do we know what the square root of 16 is? So I have 4 plus 2, and what is 4 plus 2? What did I have on the other side of the equal sign originally? 6. Did it come out to be the same? Then this checks. So I know that x is equal to 7. That is the right answer. I checked it. That is the right answer. So far, so good? You guys ready to try another one? Okay. Same page, still 343. Just look a little bit further down. This time, I don't see a radical, but I have a 1/3 power. That is the same thing as a cubed root. So that is the same thing as this. So these have the exact same meaning right here. We need to isolate it, just like we did on the last problem. And then we're going to raise each side to the 3rd power. So the first thing I need to do is isolate this. So this thing right here, we need to isolate. What numbers are not inside that purple box? -9 and 4. Which one do I need to get rid of first? The -9 or the -9. How do I make a -9 cancel out and become a 0? Add 9 to both sides. So I'm going to add 9 to both sides here. 3 plus 9 would give me 12. Now I need to get rid of that 4 out in front. What operation would I use to get rid of the 4? Divide it. Right now it's being multiplied by those parentheses. So we're going to divide it. So my 4's canceled out over there. 12 divided by 4 gives me 3. Now I'm ready to get rid of that 1/3 power. How do I get rid of that? Yep. I'm going to take this side and raise it to the 3rd power. I'm going to do the exact same thing over here. Whatever my index is, whatever my denominator is, that's the power I'm going to raise it to. So since my denominator, since my index was 3, we're going to raise it to the 3rd power. This right here is my index. What is 3 to the 3rd power? 27. I want to finish solving this for x. So what do I do to isolate x now? I have 2x plus 6 equals 27. Minus 6 on both sides, yes. 27 minus 6 gives me what? 21. And then to isolate x, divide both sides by 2. And I get x is 21 over 2, or what would that be in decimal form? 10.5 or 10.5, yes. So 21 over 2 or 10.5. We need to check this. So let's walk through our check. We have 4 and then parentheses, 2, and then we're going to make our substitution. Plus 6 to the 1/3 power. Yes, you may. Minus 9. If that is the correct answer, it should be equal to 3. So I'm putting a little question mark over my equal sign yet because I don't know that they're equal. We're going to focus all of our work over here on this side. What am I putting in the place of the x in where those parentheses are? 10.5. What is 2 times 10.5? 21. So I have 21 plus 6 inside the parentheses. What is 21 plus 6? I have 27 to the 1/3 power. I could rewrite that as the cubed root of 27. That's the same thing as the 1/3 power. What is the cubed root of 27? 27 to the 1/3 power. 3. 4 times 3? So I have 12 minus 9. What is 12 minus 9? 3. So this works. X is 21 divided by 2, or 10.5. The only time I absolutely insist that you write things as fractions is if when you divide them on your calculator, you get like a run-on decimal that runs off the screen. If it comes out to like 10.5 or 2.25, I'm okay with decimals. If you got something 9.33333333333333, leave it as a fraction. So far, so good? All right, let's try one more problem together today, and then you guys will have some time to work on the homework. All right. What do you notice about the radicals that we have here? How many radicals do I have? I have 2 of them. I've got one of them here, and I've got another one over here. One of them is isolated, correct? One of them is all alone on a side. So I'm going to treat him as isolated. What is the index on this guy right here? Index of 2. How do I make an index of 2 cancel out? How do I make that radical cancel? Second power, yes. We're going to raise it to the power of 2. And if you do it to one side, you have to do it to everything on the other side. So the entire other side is going to get squared. All right, so squared and square root are going to cancel each other out because the index matches the power. So I'm going to have just x plus 21 left on there, or left over on the left-hand side. This next piece, I'm going to bring my work over here so that we can actually see what's happening. What does it mean to square something? Times it by itself. So I have 3 minus the square root of x. That's going to be multiplied by itself. I need to use some double distribution here now. So I have 3 times 3, which would give me what? 9. 3 times negative square root of x, so minus 3 square root of x. Am I done distributing? No. I have to take this and distribute it now. Negative square root of x times 3, so another minus 3 square root of x. Negative times a negative is going to give me what? Positive, so this is plus the square root of x times itself. Negative square root of x times another negative square root of x. Yes, ma'am.
Why wouldn't it just be 1?
You sure? Okay. The other way that I could write this is like that, because I took it and I multiplied it by itself for that last distribution. This idea right here, since I'm timesing it by itself, would be squared. These two pieces right here are like terms. How do I know that they are like terms? They're both negative, yes. What am I looking for on like terms with radicals? Same index, same radicand. Do I have the same index? Do I have the same radicand, the same piece underneath the radical? Yes, so I can take those numbers in the front, the -3, and I can combine it with another -3. What is -3 minus 3? -3 plus 3 would cancel. -6. So I'm going to have -6 square root of x. Those are like terms there. How will this simplify? The square root of x, whole thing squared. What will happen there? It's going to cancel because what's my index? 2. What's my power? 2. Those are going to cancel each other out. Absolutely correct. So I'm going to have 9 minus 6 square root of x plus x. This is what I'm going to come and put on these lines over here. They did not give any room for the work for that. So 9 minus 6 square root of x plus x. Do I still have a radical? Then I have something else that I'm going to need to isolate. What do I do to get rid of that 9 out in front? I'm going to subtract 9 from both sides. What about this piece back here? Because this is something else that I need to get rid of since I'm trying to isolate my radical. How do I get rid of a plus x? How did I get rid of a positive 9? We subtracted it. How do I get rid of a positive x? Subtract x on both sides, yes. All right, help me simplify. I have x minus x. What's going to happen there? They cancel. X minus x, or it's going to cancel out. 21 minus 9 is 12. Do I have the radical isolated? Yeah. This right here is my radical. Is it isolated? How do I get rid of that -6 out in front then? What operation is connecting the -6 to the radical? Yes. Those things are being multiplied because the only time I'm going to subtract to get rid of it is if afterwards I see a plus or a minus sign. If there's nothing, it's just stuck to somebody else, then I have to divide to get rid of it. So I'm going to divide both sides by -6. What is 12 divided by -6? I have a positive 12 divided by negative. -2. How do I get rid of the radical now? Power. Power of what? What's the index? Yes, power of 2. And if I do it to one side, have to do it to the other side. Perfect. So the squared and the square root cancel each other out. I have -2 squared. What does it mean to square something again? Times it by itself. If I take a -2 times another -2, what do I get? +4. All right, let's go through and check this now. What are we putting in the place of the x's? 4. So underneath the radical on the left, I have 4 plus 21. Underneath the radical on the right, I have just a 4. Anywhere I see an x, I'm replacing it with a 4. What is 4 plus 21? 25, so I get 25 underneath my radical. What is the square root of 25? 5. On the other side, I brought the 3 straight down. The square root of 4 is what? 2. So I have 3 minus 2. What is 3 minus 2?
Why is there a question mark on top of the equals?
Good question there. We are checking to see if the two sides are equal. I don't know if the two sides are equal until I have substituted in and simplified both sides. I'm not moving things between the sides. I'm leaving them where they are and seeing if those two sides are equal. Are these two sides equal? No. 5 does not equal 1. The result does not satisfy the original equation. So it, and by it they mean x equals 4, is an extraneous solution. What we found when we solved did not satisfy. When I went in and checked it, it did not check out. When it does not check out, we say it's extraneous. So if the answer that I found doesn't actually work, what's the answer? Did we make a mistake in our solving work? We made no mistakes, but the answer still didn't work. That means there is no solution. You guys have the rest of the class period to work on the homework that is due on Wednesday. Wednesday is also when I will be giving you guys the review for the test. Wednesday and Thursday in class we will review for the test. I'll probably give you the paper review on Tuesday so you've got it in your hand. But this homework is not going to be due until Wednesday because we've got today and tomorrow where we're learning this material. Homework 6.6 on McGraw-Hill. If you want to work on it in your book, it's 1 through 23 odd and number 44.